Good day, viewers. This is Afia Ademola Johnson, your science tutor. We want to continue in our knowledge of periodic tables. So now we want to look at classification of periodic elements into periods. And from there I want to tell you that periodic elements are classified as follows. So we have number one, we have period 1 elements. We have period 2 elements. We have period 3 elements. We have period 4 elements. We have period 5 elements, and then we have period 6 elements, and lastly we have period 7 elements. So we have 7 periods, but captured on the board here we have period 1, period 2, period 3, period 4, and here this is period 6 and period 7. Now, what are the elements in period 1? Now, elements in the same period have the same number of atomic shells. For instance, period 1 elements such as hydrogen H1, and helium He2 have the same number of atomic shell, called what? K shell. So you will see what I'm talking about there. Hydrogen has 1 electron occupying K shell. Helium has 2 electrons that is also occupying K shell. Then number 2 thing to note here is that period 2 elements have K and L shell. Let's check. Period 2, you have lithium, you have beryllium, you have boron, carbon, nitrogen, oxygen, fluorine, neon. You can see that when you write the electronic configuration, you have 2 digits. 2:1. 2 is in K shell, 1 is in L shell. 2:2. 2 in K shell, 2 in L shell. 2:3 for boron, 2:4 for carbon, 2:5 for nitrogen, 2:6 for oxygen, 2:7 for fluorine, 2:8 for neon. So all of them, because they have two ratios, two digits, they have the number of digits an element we have when we have the electrical configuration is the period it belongs. So all this one belongs to period 2. Then, so period 3 elements have K, L, and M share. So look at what I'm saying. Look at period 3 now. Sodium 2:8:1. K, L, M. Magnesium 2:8:2. K, L, M. Aluminium 2:8:3. K, L, M. Silicon 2:8:4. K, L, M. Phosphorus 15 2:8:5. K, L, M. Sulfur 16 2:8:6. K, L, M. Chlorine 17 2:8:7. K, L, M. Argon 18 2:8:8. K, L, M. So that is how it goes. Then period 4 elements have K, L, M, and N share. So they have 4 share. That's why they are in period 4. Look at potassium 2:8:8:1. Calcium 2:8:8:2. Scandium 2:8:9:2. Titanium 2:8:10:2. Vanadium 2:8:11:2. Chromium 2:8:13:1. Manganese 2:8:13:2. Iron 2:8:14:2. Cobalt 2:8:15:2. Nickel 2:8:16:2. Copper 2:8:18:2. Zinc 2:8:18:2. So they have four digits. That what make them what? That. So lanthanides are in period 6, while actinides are in period 7. We are going to look at that later. So now let's now look at classification. Classification of periodic elements. Into blocks. Classification of periodic elements into blocks. In this one, you will see when we're talking about classification into blocks, the various types of elements we have. In terms of blocks, we have the SPDF, S block. Now, we have P block elements, we have D block element, we have F block elements. What are the S block elements? Group 1 and group 2 are called S block elements. Why are they S block elements? Because the distribution of electrons in their atoms end in what? It ends in S orbital. Now take note of this. Take note of this. Number one thing to know here is group 1 and 2 elements are S block elements. Why? Because the distribution of electrons in their atoms end at S orbital. Let's check. Serial number. Let's look at group 1. Group 1, electronic structure. Then let's look at group 2. Then we have electronic structure. So if you look at what is the first member of group 1, we have hydrogen, we have lithium, we have sodium, potassium. So let's go by that. Hydrogen is in group 1, hydrogen H1. configuration is 1s1. So the next one is what? Number 2 is what? Is lithium 3, which is 1s2, 2s1. Then number 3 is what? Sodium 11. That's 1s2, 2s2. So, okay, let me take so that I can have 1s2, 2s2, 2p6, 3s1. You can see that it ends in, all of them end in s, s, and s. So that is that. Then the next one, number 4, is potassium 19. That's a 1s2, 2s2, 2p6, 3s2. Then you have 3p6, 3s1. It ends in s. That's why it's s block element. So these are group 1 now. Let's look at group 2. In group 2 now we have beryllium, magnesium, and calcium. Beryllium Be4. Configuration is 1s2, 2s2. Then next one is what? Magnesium 12. That's 1s2, 2s2, 2p6, 3s2. So you can see it end in 3s in s orbital. The next one is calcium 20. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Oh, this one is 4s, sorry, 4s1. So for potassium, then this is 4s2. So you can see that all of them end in s orbital. So that is why they are what? S block elements. Now, let's go to the next one. Which ones are the p block? Let's go to number 2. Now, group 3 to group O elements are p block elements. Now, why? As the distribution of electrons in their atoms end at p orbital. An exception is helium He2, which is whose configuration is 1s2, which belongs to s block, is the only one that is behaving like that. So every other ones, let's check what I'm talking about here. Let's first of all check for group 3. For group 3, then let's look at the electronic configuration. In group 3 here I have boron and aluminium. Boron 5. And I have aluminium 13. Let's check. 5 is 1s2, 2s2, then 2p1. So that is what we have there. Now the next one is aluminium. We have 1s2, 2s2, 2p6, 3s2, then 3p1. Let's check. 6, 7, 8, 9, 10, 11, 12, 13. So the distribution of electron end in 2p, this one end in 3p. That's what makes it what? P block element. Then let's check group 4. Let's check group 4 elements. For group 4 elements, group 4, then I come to electronic configuration. Electron configuration. So now, group 4, I have carbon and silicon. Carbon what? Carbon 6, and silicon 14. So this is 1s2, 2s2, 2p2. So you have P. Then here you have 1s2, 2s2, 2p6, 3s2, 3p2. So if you count everything now, you have 6, 7, 8, 9, 10, 11, 12, 13, 14. Then that's that. So the distribution of electrons end in what? In 3p. So that makes it what? P block element. So let's check another one here. Let's check another one here. Now, another one we have here. Let's look at group 5. Group 5. In group 5, I have what? Nitrogen and phosphorus. Nitrogen 7 and phosphorus 15. So I have electron configuration. So for nitrogen 7 we have 1s2, 2s2, 2p what? 6. If I okay 2p what? This is 4 already. I need how many? 3 to make 7. Then this is 15. I have 1s2, 2s2, 2p6, 3s2, 3p3. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is that. So it's in group. So now, then coming here, let's look at group what now? 6. And let's look at the electron configuration. Electron configuration of group 6. In group 6 now I have what? Oxygen 6, oxygen 8, and I have what? Sulfur 16. Oxygen 8 and sulfur 16. So now, for oxygen 8, I have 1s2, 2s2, 2p what? What do I need to add for? That's 2p4. So 4, 5, 6, 7, 8. Then end in p orbital. Then sulfur 16 will now be 1s2, 2s2, 2p6, 3s2, 3p4. Let's count. 4 plus 2, that's 6 plus 6, that's 12. 13, 14, 15, 16, which is what we have here. Then the next one, we go to group 7. Group 7, and look at the electron configuration. Electron configuration. Now, in group 7, I have fluorine, for example, F and 9, and I have chlorine Cl17. For this one, I have 1s2, 2s2, then 2p what? To make it 9, I have to, what do I need to add to 4 to make it 9? 4, 5, 6, 7, 8, 9. That's 5. 2p5. 5, 6, 7, 8, 9. Then chlorine, this is 1s2, 2s2, 2p6, 3s2, 3p5. So I have 5, 7, 7 plus 6, that's 13, 14, 15, 16, 17. So then I have group O. For group O and electron configuration, I told you the only one exception to this is that what? Is helium, which is S block, residing in P block. So we have neon and argon. Neon 10, and we have argon 18. So here we have 1s2, 2s2, 2p6. So here we have 1s2, 2s2, 2p6, 3s2, 3p6. So if you add the powers together, you have 6, 7, 8, 9, 10. So for this, here you have 6, 7, 8. This is 6 plus 12, 13, 14, 15, 16, 17, 18. So you can see that here now, what would I say here? Now, in what I have here, I can do something like this. That, okay, group 1 and 2, are S block. S block. Group 3 to group O, with the exception of helium, are P block. Now, the next one we want to look at now are transition elements are what? D block. How? They are D block elements. Let's check that. The first transition series. So let's check that. Let's go back to, okay, we are going to this board now. So now I want to tell you here, point number 3 to know here is that the first transition series are D block elements. Why are they D block elements? As the distribution of electrons in their atoms and in what? In D orbital. And in D orbital. Let's check that. Transition element, first transition elements, then electron configuration. So the first one is scandium. We have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So let's look at scandium 21. We have 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. You can see that before I put 4s2, and when you now add up everything here, 6 plus 6 is 12, 30, 40, 50, 60, 70, 80, 90, 20. The remaining one is put here. 3d is filled last. So now let's look at number 22 now, which is titanium. Titanium 22. Now that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2 first. The remaining two. Now let's now count. 6 plus 6 is 12, 30, 40, 50, 60, 70, 80, 90, 20. The remaining two is now put here. So 3d is filled last. So number 3 here is what? After titanium is what? Vanadium. Vanadium what? Vanadium 23. So vanadium 23 is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. So from here to here is 20. The remaining 3 is now put here. Now, then number 4. Then apart from that, we have apart from vanadium, we have chromium. Chromium 24. So you should know that this is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. So the remaining this one, I told you that copper and chromium end in 4s1 and double fill this one. This one is going to be 4. It should not be 5, 3d5. But 3d is filled last. Now number 5. Now number 5 now is what? Apart from chromium, we have manganese. Manganese what? Manganese 25. So that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. This one will now have 5 here. So that is that. The next one is what? Is iron, Fe26. Now this one is what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. Then you have put 6 here. So that is that. Then number 7. That's after iron, we have cobalt. Cobalt 27. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. Then you have 7 here. Then next one, number 28. That's nickel. Nickel, N what? Ni28. That's 1s2, then 2s2, 2p6, 3s2, 3p6, 3d, 4s2. Then after that, then the remaining 8 is now put here. Then the next one is number 9. Number 9, which is copper. That's a Cu29. Cu29. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s1. Then this one is double filled. Don't forget, it's supposed to be 3d9. But if 4s is going to carry 1, then this one will not be what? 3d10. Then lastly, we have zinc. Zinc, number 10, that's zinc 30. So this one is 1s2, 2s2, 2p6, 3s2, 3p6. Then we have what? 3d, 4s2. Then the remaining 10 is put n. So you can see that in transition elements, so the first transition elements now are called d block because the distribution of electrons in their atom end the what? In d orbitals. So in lanthanides and actinides, if you are able to write the electronic configuration, you will discover that the distribution of electrons will end at f orbital. That is why they are what? They are called f block elements. They are f block elements. So that is that. So we are stopping this lecture here. In the next class, we'll be looking at classification of elements in the periodic table into metals, non-metals, and metalloids. Thank you very much. See you in the next class. God bless you. I remain Afe Ademola Johnson. Please try to comment. If there's any issue, let me know. You can chat me on my WhatsApp number. You can put your comment in the comment section. Please do subscribe in my YouTube channel titled Afe Ademola Johnson. And please try to share this video and like it. God bless you. Bye for now. Afe Ademola Johnson. Thank you. God bless you.